Geometric distribution. Now, geometric distribution is a special case of the negative binomial distribution. Remember, in negative binomial distribution, we are talking about how many trials does it take to get k successes. So if k is 1, it means if we're only talking about how many trials it takes to get the first success, then that becomes geometric distribution. There's a special case of negative binomial distribution where we are interested in the number of trials to get k successes, to get 1 success. So the probability function in this case is given as f of x is equal to p power x, p power k, actually p power 1 because k is 1, and 1 minus p power x minus 1, where x is equal to number of trials for first success, and p is the probability of success in each trial. Okay. So even if we don't know geometric distribution, but we know the negative binomial, we can still get by. It's just that the formula looks more clean. And it's easy to see why this is the formula for geometric distribution, because if we go back and we look at the negative binomial. So here, now we're talking about k is equal to 1. So if you substitute k is equal to 1 here, this becomes x minus 1 combination 0, and anything combination 0 is 1. So that's why this term is gone, and k is 1. So this becomes p power 1, and this becomes 1 minus p power x minus 1. And that's exactly what the geometric distribution formula is, p times 1 minus p to the x minus 1. If you go back, p times 1 minus p to the x minus 1. So let's apply this to hit this one. According to a study by a group of University of Massachusetts, about 66.3% of the 20 million persons in the country who take Valium are women. So assume the figure to be a valid estimate. Find the probability that on a given day, the sixth prescription written by a doctor for Valium is the first one prescribing Valium for women. So probability that the prescription of Valium is for women is 0.663. And so we want the sixth prescription to be the first one. So x is 6. F of x equal, f of 6 equals p is 0.663, and then 1 minus 0.663 power x minus 1, so power 6 minus 1. So we should just mention that if this is the PMF, then x is said to have negative binomial distribution. And we get 0.663 times 0.337 power 5. That's 0.0029. And then the second part here is back to the hypergeometric distribution. And I'll just leave that since we've already discussed hypergeometric distribution.